Do you remember the time when you first learned about promises in JavaScript? It was so different. We were trying to fetch a value from some API, but the value wasn't available in an easy way. It was wrapped in a promise object and we could only access it inside a then callback. It was a pain to get that value out and the code was ending up like a hack on top of a hack. Well, as we played more with it and gained experience, things got more clear. We started to learn how to look at promises and in general asynchronous code differently. Effect is similar in that sense. You need to rewire your mind to think like effect. But the good news is if you're already comfortable with promises, coding in effect should be pretty familiar. In this video, we will take a closer look at promises, and by understanding its power and also its shortcomings, we then transition our existing knowledge from promises to effects. Let's say we are provided with a SDK that has a function called findBook. We don't know how internally findBook works, but what we know is it receives a string for searching a title of a book, and it returns a promise of the first book it finds. Looking at the type of the book, we know that it's an object with two properties on it. The complete title of the book, which is of type string, and the price of the book, which is of type number. So we decided to give it a try and call it to find the Hobbit book. What we are really interested in is, will we get a free shipping if we buy this book? We know in order to get a free shipping, the total price after our 15% discount should be above $50. So in order to find that out, we extract the price, then we apply our 15% discount, and finally we check to see if the total price is above $50. Let's expand this and keep track of the promise objects at each step. Looking at this, we can see the pattern of how the data is flowing through the promises. If we look closer, this is actually a transformation between promise objects. If what we are doing here is simply converting one promise to another, then we can model these transformations simply by functions. We just need to design a function like quote-unquote and then that internally uses the promise then method and reorganize the inputs and outputs. The and then function receives a callback same as the then method. It returns a new function that receives a promise as an input and returns a new promise as an output. As an exercise, try to define this and then function for yourself and let me know in the comments what you think. But don't get too overwhelmed by the implementation of the and then function. The implementation of and then is kind of an unnecessary detail for us right now. What we care here is such a function exists, either from a library or we write it ourselves. So we could come up with functions to transform and convert one promise to another. Let's look at the types in our example. The first callback receives an input of type book and returns a number. By knowing the type of our callback, we can now say promise 1 is of type promise of book and promise 2 is of type promise of number. The promise acts like a wrapper around our types, and our and then function seems to lift our initial callback and creates a new function that its input and output are wrapped in promise. Continuing with our function call chain, our next Lambda function is transforming a number to number. So the corresponding function from and then would be from promise of number to promise of number. And following the same logic, we can raise our number to Boolean function to a function from promise of number to promise of Boolean. By using the type system, if we only focus on implementing each callback function perfectly, then they will automatically work perfectly in the context of the promise. You can also reuse and move pieces around easily. This is because we are coding and designing at the type level and not the value level. We came up with a framework that makes us flexible but also safe for possible human errors. But wait a second. What I'm saying works when our promises always resolve successfully. What happens if one of our promises rejects? For example, let's say after working with this SDK, we learn that sometimes we get books with negative prices. In those cases, we want our application to recognize these situations and behaves accordingly by rejecting the promise. So when the price is less than 0, we return a rejecting promise with a string bad value, otherwise returning the price. Since we know we have an error, then at some point we need to catch it, otherwise it breaks the app. Same as what we did for then method by introducing the and then function, let's create a new function for catch method and call it quote-unquote catch all. Then what would be the output of this catch all callback? Since the input type of the next callback function is number, then the type of the output of catch all here should be promise of number. Okay, only by looking at the types in our code, we could figure out what should be the output type of the happy path for our catch all function. But what about the rejection path? In other words, by just looking at the types, can we tell what is the type of catch all input here? Let's visualize this. Promise chains are handling two channels of data flow at the same time. One is for the happy path, and the other one is for the error or rejection path. We already know the types of our happy path step by step. But what about the error path? Based on the promise design, error paths can be anything. So compiler or type checker cannot give us anything better than any for our catch-all callback inputs. Just by focusing and looking at the catch-all callback, we don't know how to deal with this. We deviated from our framework of thought for creating perfect functions at the type level. We lost the benefits of using compilers in writing type-safe code when it comes to handling the error path in promises. This is one of the downsides of the promise design. For the sake of completeness, let's handle the error in our catch-all function. In case that the input is a string bad value, we want to recover from the error with price 0, and in case of any other errors, simply continue to pass the error along. Something that may look strange here is the return type of these callbacks. These two callbacks are returning promises. Let's focus on the type of the first one. This callback is returning a promise of number, while if we look at the second callback function, it is of type number to number. The output of the first function is not compatible with the input type of the second function. And the promise container seems to cause this incompatibility. It seems that and then knows how to wait for the promise, unwraps it, and only sends the number inside it to the next function callback. This is actually one of the most powerful tools we have in functional programming. This unlocks a whole new set of capabilities for us to code and design our solutions, and lets us chain these kind of functions together along with our simple transformations. In functional programming, each of these scenarios have a different name. For when we are simply transforming types, we have a map function. And for when we need to flatten two nested promises, we have flatMap. Doesn't this remind you of arrays in JavaScript? This similarity is not a coincidence. The reason we are using same map and flatMap names for both promise and array is that they are following a same pattern. Just to mention the name of the pattern, we say promise and array are both monads. I won't get more detail on monads in this course, but if you're interested to learn more, check out my other course on functional programming in TypeScript. For the sake of this course, let's stick with our convenient and then function. Looking at the catch-all, we are in a similar situation. Except since we are tapping into the error channel, the input type can be anything. But the output type of its callback should be pluggable to the next and then or catch-all callback. Honestly, by just looking at catch-all callback type for promises, it gets confusing how things are connected. We will see how Effect fixes this, but before that, let's run our code with a couple of different inputs. For the Hobbit book with a price of $70, by going through our pipe, we receive an output true in the context of promise, indicating that book qualifies for free delivery shipping. In case of a price $55, we receive false, meaning we need to pay for shipping since the price after our 15% discount will be below $50. If our input price is -18, our code captures it as an error of a string bad value, but later on it recovers from it in the catch-all function with a price of 0, and that means no free shipping for books with negative prices. Alright, so far so good. But we missed an important case. What happens if our findBook function couldn't find a book and returns a promise rejection? We totally forgot about this and never considered this situation in our code. So our app crashes in production, and that's definitely not a desired behavior. How come we missed this? How come compiler didn't catch this at the compile time? The reason is Promise is not giving us a type-safe environment for handling errors. In contrast, if Promise was tracking the possible types of the error path same as the happy path, we would have never gotten into this situation. Because if the possible types for errors at each step is explicitly specified, then at the end of our pipe, we will see that we are still not handling the not found error. Even better, compiler knows that we are not handling the not found error and can give us hints on our miss. This is one of the issues that Effect beautifully addresses. Let's say the SDK is providing another function, same as findBook, but instead of promise, it returns effect. As you can see, the code for the effect here is almost the same as the promise version of it. Same as promise, effect wraps and tracks the type of the happy path in our code, but what it also does is tracking the types in the error path of our code. Effect provides us with means to know what types we are dealing with at each step. This is great, but we are not done yet with the Effect benefits. With promises, as soon as we create them, they start running their chain of calls. This is different for Effect. In Effect, when we are creating a pipe and chain of functions, we are simply writing instructions on how we want our application to work. We can store this in a constant or a variable if we want to. This means that we can rerun this set of instructions multiple times in one run of our application. We can run them sequentially or in parallel. We can also mix and match this with other tasks and effects to create new effects until we get to our final program. But one of the benefits I absolutely love about Effect is how beautifully it handles dependency injection. Not only Effect tracks types for happy path and error path, it also tracks if there are any external requirements each step needs in order for it to be completely executable. For promise version of findBook function, we didn't have any control on how the function does its side effects. Is it reading from a file or database, or does it walk over the network by doing a fetch call? We didn't know or have any control over it. But with Effect version of the findBook function, the output of the function can explicitly mention in its type that it relies and depends on the fetch service. This means in order to run this code, we need to specify fetch implementation at some point in our application. This can be a mock implementation or the real implementation of the dependency. For example, let's provide the fetch live implementation for fetch dependency here. Then the rest of the chain doesn't depend on fetch dependency anymore, and it is ready to be run. In practice, we postpone providing the implementation for the requirements and dependencies all the way to the edge of the application. In the following videos, we will look deeper in each of these parts. But till then, thank you for watching this video. Please like and subscribe, and I will see you in the next one.